Hello and welcome to this lesson on dissolving hydrogen halides in water. In today's lesson, we will explain the formation of acidic solutions when hydrogen halides dissolve in water. Let's get started. When hydrogen halides, such as hydrogen chloride, HCl, hydrogen bromide, HBr, and hydrogen iodide, Hi, dissolve in water, they form acidic solutions. Let's explore how this happens and generalize this pattern to other halogens. First, let's understand the formation of hydrogen halides. Halogens, which include chlorine, bromine, and iodine, react with hydrogen gas, H2, to form hydrogen halides like HCl, HBr, and Hi. These hydrogen halides are steamy gases at room temperature. Now, when these hydrogen halides dissolve in water, they undergo a process where they dissociate into their respective ions. For instance, hydrogen chloride, HCl, dissolves in water and dissociates into hydrogen ions, H+, and chloride ions, Cl-. This dissociation can be represented by the following equation. Similarly, hydrogen bromide and hydrogen iodide will dissolve in water to form hydrogen ions and their respective bromide and iodide ions. The presence of hydrogen ions, H+, in the solution is what makes it acidic. When we dissolve hydrogen halides like HCl, HBr, and Hi in water, we get strong acids, meaning they dissociate completely into ions. This results in a high concentration of hydrogen ions, making the solution highly acidic. In a later unit, we will discuss acidity and dissociation in more detail, but for now, just know that the concentration of H+ ions determines the acidity of a solution. The higher the concentration of H+, the more acidic the solution is. Interestingly, not all hydrogen halides form strong acids. For example, hydrogen fluoride, HF, dissociates only partially in water. This is called a reversible reaction, meaning that some of the dissociated ions combine back into HF and H2O. We will look at reversible reactions in great detail in a later unit. Because HF does not dissociate completely, it instead forms a weak acid solution, as it has fewer hydrogen ions compared to strong acids like HCl, HBr, and Hi. To summarize, when hydrogen halides dissolve in water, they form acidic solutions due to the release of hydrogen ions. Strong acids like HCl, HBr, and Hi dissociate completely, producing a lot of hydrogen ions, whereas weak acids like HF dissociate only partially. By understanding this pattern, you can predict that other hydrogen halides formed by halogens will also create acidic solutions when dissolved in water, the strength of which depends on the extent of their dissociation. In today's lesson, we discovered how hydrogen halides are formed. We also examined how hydrogen halides form acidic solutions when they dissolve in water, focusing on group 7 elements in the periodic table. By understanding these reactions, we obtained insight into the predictable behavior of group 7 elements and their compounds in aqueous solutions. This lesson has therefore explained how the periodic properties of halogens influence the acidic nature of their solutions.